A study just published by the United States government reports the discovery that low-dose radiation is so safe, evacuations from future nuclear disasters may be unnecessary. If another event like Fukushima occurs, the public could be allowed to live in the fallout zones, spared from the inconvenience of relocation and compensation for damages. While the monetary savings for the nuclear industry would be enormous, does this new study actually support repeal of current evacuation policies? In this video, we'll observe that this new study is contradicted by extensive, higher quality, pre-existing research that the authors entirely ignore. Moreover, we'll observe, based on prior research, how the results of this study were a predictable consequence of only exposing the mice to radiation for 35 days. In this new study, researchers at the Massachusetts Institute of Technology set out to see if exclusion zones placed around nuclear accidents are really necessary. It should be noted that MIT does not deny it has an agenda to promote nuclear energy. In fact, 2 weeks after this study was published, MIT announced being awarded a grant from the Department of Energy to promote acceptance of nuclear energy against public opposition. The MIT press release states, quote, "The nuclear enterprise has long faced difficulties in gaining the broad social acceptance needed for success. Reliance upon public education efforts continues to be the main and largely unsuccessful tactic to achieve acceptance. This project will develop a model for the social acceptability of nuclear projects." End of quote. So big brains at MIT will be dedicated to forging a sales pitch for nuclear energy, so persuasive the public will swallow it hook, line, and sinker. Is this academia? MIT's pro-nuclear activism is nothing new. For example, in 2003, an MIT report on the future of nuclear energy started out with the goal of a threefold expansion of nuclear energy capacity by 2050. The MIT report recommended government subsidies to achieve its nuclear growth ambitions. One reason many universities actively promote the nuclear industry is that they have nuclear engineering departments. In contrast, how many universities have solar or wind engineering departments? So there's an inherent pro-nuclear bias within academia. The MIT study should also be considered in light of the fact that since the Fukushima disaster, a disturbing theme in nuclear advocacy has been not how can we prevent the next Fukushima, but how can we prevent evacuations from the next Fukushima. The MIT study was designed to address this issue and is now being used to advocate leaving the public stranded in the next nuclear disaster zone. Let us now turn our attention to this study. In this new study, the researchers at MIT exposed mice to continuous low-dose rates of radiation for 5 weeks and then looked for signs of persistent DNA damage. The researchers used continuous dosing because it's a better model of living in a fallout-contaminated area than a sudden acute dose of radiation. The researchers felt that radiation exposure for 5 weeks, that's just 35 days, was a reasonable model of indefinite exposure. In fact, when asked if 5 weeks were sufficient, one of the researchers confidently predicted, quote, "You could probably leave the mice there indefinitely and the damage wouldn't be significant." End of quote. However, even as she said that, her prediction of perpetual safety had already been tested and failed. Research by Tanaka and colleagues, published in 2009, exposed mice to continuous radiation at an even lower dose rate than the MIT study. In fact, Tanaka and colleagues used just 1/3 the dose rate, 1 versus 3 milligrays per day. And while the MIT researchers exposed their mice to radiation for just 35 days, Tanaka and colleagues exposed their mice continuously for almost 2 years. Here's a graph of chromosomal aberrations in Tanaka's mice. Each square represents a mouse exposed to 1 milligray per day. Along the right-hand y-axis are its rate of chromosome aberrations per 100 cells. Chromosomal aberrations are DNA strands that were broken and repaired, but the repair was flawed, resulting in a persistently deformed DNA strand. While everyone has some accumulation of chromosomal aberrations from normal living conditions, scientists consider them to be biomarkers of cancer risk. Returning our attention to the earlier study from 2009 by Tanaka and colleagues, along the bottom x-axis of the chromosomal aberration graph, we find the cumulative dose each mouse received. And because the dose rate is 1 milligray per day, the x-axis also counts days of exposure. As we can see, the trend of aberrations increases over time. However, this trend isn't necessarily remarkable, since aberrations naturally increase with age, and 600 days is most of a mouse's lifetime. What makes this upward inclination significant is its difference from the trend of the control population of mice, which we now include. As we can see, the upward slope of the exposed mice is much steeper, and in fact, the difference is statistically significant. Tanaka and colleagues used 3 measures of chromosomal aberrations for the 1 milligray per day dose group, and each found a statistically significant difference from the control mice. So why did Tanaka and colleagues find a significant dose response at a lower dose rate? A likely answer is that the null results the MIT authors reported could have been predicted from the previously published findings of Tanaka and colleagues. Here we overlay the cumulative dose that the MIT mice received onto the full scale of Tanaka's study. Looking only at the mouse data near the MIT study range shows no perceptible difference between exposed and control mice within this narrow range. According to a scientist whom I consulted, given the increase of genetic damage Tanaka found, in order to detect a significant effect in the green highlighted region, over 500,000 cells would need to be examined. Far more than Tanaka and colleagues examined, and far more than is feasible with the small number of mice MIT used. And so the MIT study's finding of no effect was a predictable consequence of the study's extremely limited design. Moreover, the MIT authors' confident prediction that unlimited exposure to radiation 400 times higher than normal would be harmless had already failed in a study using a dose 3 times less. What is even more troubling is that not only had there already been lab animal research from which to predict nuclear accident genotoxicity, but there has also been research on chromosomal aberrations in human beings exposed to the Chernobyl disaster. What better model of humans in a nuclear disaster zone could there be than humans in a nuclear disaster zone? To get a sense of the extent of research into genetic damage associated with the Chernobyl disaster, here's a Google search on the terms Chernobyl chromosomal aberrations. Notice that we get an automatic link on top to scholarly articles. This means these terms call up an unusually large amount of peer-reviewed scholarly research. As we scroll down, we can see the returns are almost all to science journals, reporting increased chromosomal aberrations. Yet the MIT study fails to acknowledge the existence of any pre-existing research on human genetic damage associated with nuclear disasters. Why should human research be excluded when considering, as the MIT authors explicitly do, abolishing current public protection standards? When confronted with a large body of research on a particular topic, as we are here, meta-analyses or systematic reviews are useful points of reference. Fukushima and colleagues conducted such a meta-analysis of chromosomal aberrations in children exposed to radiation. They reported, quote, "The main sources of knowledge on gene damage in children exposed to radiation are studies performed after the Chernobyl nuclear power plant accident in 1986. Overall, the evidence from the studies conducted following the Chernobyl accident, nuclear tests, environmental radiation pollution, and indoor accidental contamination reveals consistently increased chromosome aberration and micronuclei frequency in exposed than in referent children." End of quote. As Fukushima and colleagues state, Chernobyl research uniformly shows elevated chromosomal aberrations, and even in spite of the fact that evacuations were enforced. So it obviously follows that had those living around Chernobyl been left in the exclusion zones, as the MIT researchers propose, their genetic damage would have been far worse. This table lists the genetic damage studies Fukushima and colleagues reviewed. Highlighted are those studies involving children who lived around Chernobyl. Red table rows highlight the exposed dose groups, while green rows highlight the control groups. Now highlighted on the right-hand column are measures of the effect. The green row controls are set to number 1 to reflect the normal level of genetic damage. As we can see, all the values in the exposed groups are greater than 1, meaning the exposed children had increased chromosomal aberrations in every non-zero dose group in every Chernobyl study. Now notice the doses from the studies that we can easily compare to the MIT study. The doses in Fukushima et al. Associated with elevated genetic damage in children are almost all much lower than the MIT study dose, expressed in comparable units. So these lower doses in a real-world nuclear disaster were associated with elevated chromosomal aberrations in humans. To Fukushika's table of studies, I've added a red check mark to each dose group in each Chernobyl study with a statistically significant increase of genetic damage. Of all 19 exposed dose groups, 100%, that's all, showed elevated CAs, or chromosomal aberrations. 58% had statistically significant elevations. 21% had non-significant elevations. And 4 dose groups lacked the data needed to calculate significance. Therefore, no pre-existing evidence supports the genetic safety of children in nuclear accident fallout zones. And the weight of pre-existing evidence contradicts the MIT thesis that exclusion zones are harmless. In fact, Fukushima and colleagues note that evacuated children, quote, had almost 10 times more dicentric and ring chromosomes than controls. Such increased values of these types of chromosomal aberrations could reflect genomic instability, a phenomenon of increased rate of acquisition of alterations in the mammalian genome proposed to be a driving force in carcinogenesis." End of quote. This meta-analysis of Chernobyl-induced genetic damage in children merely scratches the surface of an extensive body of literature consistently demonstrating Chernobyl-induced genetic damage in people of all ages. Why was this evidence excluded from the MIT study, when the stated purpose of the MIT study was to consider the potential for nuclear accidents to cause genetic damage? MIT's presentation of its study as the first ever examination of the genetic risk of living in a nuclear disaster zone is pure science fiction, not fact. In closing, let's observe a real-world example of the level of radiation the MIT researchers suggest is safe for the public. The dose used in the MIT study would be measured on a Geiger counter at around 120 microsieverts per hour. Here we see a Geiger counter within sight of the destroyed Fukushima Daiichi nuclear power plant. Near the ground, the dose rises close to 120 microsieverts per hour, the same dose the MIT researchers would have us living in. Now notice the noise. It sounds like static. That sound represents a blizzard of invisible radioactive particles and rays striking the thin gold-colored Geiger-Müller tube in the upper left corner. Normally that tube, about the size of a cigarette, would produce a few dozen audible clicks per minute, each click representing one radioactive particle or ray striking the tube. But near Fukushima, the radioactive emissions striking the tube are around 14,000 per minute, or about 240 impacts per second. And each of those impacts could damage DNA and lead to cancer if the damage was imperfectly repaired. While our bodies successfully repair the vast majority of DNA damage, the idea that we could be inundated with such an increase in genetic insults and suffer no ill effects defies both common sense and science.
We need to get subscribed and get this unity stronger and beat YouTube at their own game. Okay, that's what this is about. Like I say, go to the remix button, hit the remix button. That way you'll have this video and keep up with this. Otherwise, YouTube's just going to control us, guys, and it's really bad.